So hi everyone, thanks for joining. Today's topic is going to be on Ridge-to-Reef and Icefield-to-Ocean, collaborative research in extreme environments. And I will leave it to Abby Lynch to kick us off.
Great, thanks. Hi, I'm Abby Lynch, and I'm a research fish biologist with the National Climate Adaptation Science Center, and it's my pleasure to introduce the two speakers for today. First, we have Dr. Stephen Gray, who is the director of the Alaska Climate Adaptation Science Center. Dr. Gray's research explores the interplay between climate variability, climate change, and natural resource management. His most current work centers on disentangling the roles of temperature and precipitation in driving runoff from mountains and glacier-dominated systems. And our second speaker is Dr. Mary Vaughan Johnson, who serves as the Federal Director of the USGS Pacific Islands Climate Adaptation Science Center. In this role, Dr. Mary Vaughan draws on her background working on assessing agricultural conservation practices, coordinating across multilateral government, academic, and nonprofit institutions, and working to promote science-based solutions to local, regional, and global challenges. Dr. Mary Vaughan Johnson brings a systems-oriented perspective to developing multifunctional solutions to climate change-related challenges posed to cultural and natural resources.
Thanks so much, Abby, for that introduction, and thanks also to Phil and company for arranging this, and for everybody that was able to join us today. In the interest of time, I'm going to jump in and start sharing my screen here and go through really our story about how we got here and how we came to develop this collaboration between the Pacific Islands Climate Adaptation Science Center and the Alaska Climate Adaptation Science Center, what we refer to as the PIAC collaboration, and you're going to hear that a lot today. All right, so we like to tell stories as part of the PIAC collaboration, as this is really a part of the cultures of our region. So I'm going to go through this and kind of tell you the story, at least from the Alaska perspective, of how we got here. And this starts in kind of an unusual way with a number of us from what was at the time the Alaska Climate Science Center, actually going to Guam, of all places, bringing a number of folks from the center, including a number of our fellows there, and meeting with our friends, our collaborators, eventually from the Pacific Islands, in the setting of the Island Sustainability Conference that was held there in Guam. And I know it's a little unusual that this would be part of our origin, given that we were in a place that looks like this, when in actual fact we live and work in a place that looks like this. But it actually made a lot of sense in that we were all there to talk about the challenges of doing the work of climate adaptation in island settings. Alaska, you may not think of it if you're not from here, but Alaska is very much a place that it's characterized by, or islands are very much a part of life here in Alaska. Many of our communities are actually located on physical islands, such as here in the picture that you see, Dutch Harbor on Alaska Island, and out in the Aleutians. And that in and of itself presents a number of challenges to doing the work of adaptation. First and foremost being that it's just very expensive to do the work of adaptation here. Say you need to build a seawall, or you need to respond to some particular challenge or threat. It can just be very expensive because everything has to come in on a boat or a plane, and the logistical problems that presents are enormous. And this is something also, of course, that our friends in the Pacific Islands deal with on a day in, day out basis. For us in Alaska, though, it's more than just the physical islands, in that many of our communities are what we think of as islanded. In essence, many of our communities, such as the picture that you see here, Juneau, the capital of Alaska, is for practical purposes an island because you have to take a boat or a plane to get there. And there's no train, there's no road that links it to the outside world. So again, those challenges of doing climate adaptation are very much the same as they are in the island communities of the Pacific. But where this really started to take off and we really started to see the potential for collaboration is when we talked about specific challenges to doing research in these island or islanded communities. I want to illustrate that, or I can illustrate some things that resonated with our partners, our friends in the Pacific Islands. If you'll bear with me, I'll show you a short video here that speaks to some of these issues. And, I think in many ways really resonated with our partners in the PIAC collaboration.
So I woke up on that July morning to a sunny, beautiful day. And the last thing you expect to hear on a sunny day in Southeast Alaska is that your river's flooding. We were surprised because we really didn't have any rain to speak of in the week previous. And the river was rising and rising. We didn't have a good understanding as to why.
We didn't know where the flood was coming from, but we suspected it was a glacier lake outburst flood, originating from an ice dam lake known as Suicide Basin. There was a group of us that jumped into a helicopter. We started flying up the Mendenhall Valley, and I remember very clearly seeing people standing in yards, standing on their bridges, looking out at this flood. So when we arrived at the basin, it was quickly apparent that this was in fact the source of the flood. You could see that the ice in the basin had collapsed down. There were stranded icebergs indicating the old water line at the beginning of the flood. We landed the helicopter. The ice was actually still cracking around us because the basin was still settling, and it was pretty clear that the peak of the flood had already passed because the basin was mostly drained.
A couple of things I'm sure you noticed about that video. It's a very different looking place in many ways than the Pacific Islands. But again, I think that particular project and projects like it that the Alaska Center has been involved in, again, really resonated with our partners in that it illustrated a number of common challenges. Particularly the fact that we're working in remote locations, that it's very difficult and really expensive to access many of these places. Also, something that's there is that there's just really a profound lack of baseline data, observations to help us understand things as they unfold. And we also have to really have a creative approach to monitoring and measuring the environment in these situations, because, again, the infrastructure doesn't exist. And these issues, again, of accessibility really necessitate that. And then probably one of the most important things that will eventually lead to where we are today is understanding the direct connections between what's happening in these systems and the way that people live and make a living. On top of that, of course, being the idea of how just challenging it is to do research and adaptation in these island or islanded communities. But things really, I think, started to take off, or the next step in the story was looking at what was similar in the characteristics of the landscapes in our two regions. Illustrate that starting here. This is actually a picture not of Hawaii, even though it's green enough that I suppose it could be, but these are the Chugach Mountains, about 10 miles from where I sit right now. And these are peaks that rise up 6,000 or more feet within just a few miles of the coastline. So an extreme gradient there going from the ocean to the ridge top here. And a key feature of what's going on here is that, these are very short, steep watersheds, but what is happening high up in the watershed then affects all the way out downstream into the near ocean and the ocean systems as they're connected by water. Very much, again, like systems that we see in the Pacific Islands. So we're looking at this, or we were looking at this already in Alaska from the standpoint of characterizing them or thinking about these as ice fields to ocean systems. Again, where the impacts of climate change were being manifest in the high countries, up on the ridges, in very real ways, but communicated through the flow of water throughout these systems. And that then led to the next part of our exploration here, and then thinking about what this meant in a cultural context, and essentially getting people from both of these regions together, leadership from these regions, scientists working in these regions, people who were fellows or other members of our various communities together to talk again about how these systems relate to the communities around them. And in particular, thinking about concepts of how in the Pacific Islands in particular, about how the structure of these landscapes, again, was built into the very cultural fabric and the way that people have traditionally managed and interacted with their environments to be very much what brought us to this place today. So then thinking about, again, the cultural context, here illustrated by a picture of some fish ponds in the Pacific Islands and what that means. And again, this sort of being the last piece of the puzzle to get us kicked off as a collaboration, thinking about these strong linkages between the landscapes and cultural identity, that very much the landscape itself is part of the culture of the people that live there. Also, that these landscapes, these ridge-to-reef and icefield-to-ocean landscapes, are vital for the food that they provide, the water that they provide, the economic value through tourism or other mechanisms, whatever it might be. And then, in truth, looking at these systems and looking at what had been done previously, thinking about the fact that there's just really limited efforts to incorporate local cultural perspectives and knowledge into the resource or into the research process that would then feed into climate adaptation. So just, again, a story to kind of bring you up to speed on how we got here and the background or the foundation on what we've been building. And with that, I'm happy to hand it off to Mary Vaughn.
Thank you, Steve. It's been a pleasure working on PIAC because, of course, as you could tell from the picture of the unmasked people, this was established prior to COVID. So I came to the Pacific Islands just a little bit after that. So it's been really nice to be able to get involved with something that was already being formed, even though, of course, COVID has created a few stumbling blocks for us as we've continued to grow this relationship. But one of the things that I just wanted to share, I'm sure that many of you who live in I heard someone refer to it as the upper 49 the other day. When you're out here in the Pacific, you're probably used to us showing you how big our regions are compared to the United States, 48. And so I just thought it was pretty interesting for the Pacific Islands CASC and the Alaska CASC to be collaborating, because really by bringing these two regions together, we are doubling the footprint, the environmental footprint of the CASC impacts, comparable to the entire continent. Tripled, so we're doubling it. Anyway, what I would like to go over is some of the goals that PIAC now embodies as we move forward with this program. One is, and you'll understand as I go through these that they definitely resonate with what Steve just shared in terms of how they were formed and what the needs were that were identified. And so these are the goals that we've put forth to address the needs that Steve just shared. So one is, of course, science. most of you who are on the call today are scientists, so you will appreciate the fact that PIAC's overarching goal is to enhance the science around these watersheds and to understand some of the connectivity, as we call it, Mauka to Mackay, or Ridge-to-Reef and Icefield-to-Ocean in Alaska. So it's to connect the upland processes and the midland processes to what's going down in the shore processes across both systems. Another goal is to grow the relationships that the CASC networks have. So one of the things that's unique about the CASC networks within the USGS system is the relationship that we have with universities. I don't know how familiar everybody on this call is with the way that the CASCs work, but to give you a little primer, what we are is a USGS center who is partnered with a consortium of universities. So in Alaska, their main consortium partner is the University of Alaska at Fairbanks, although they have consortium members at Alaska Anchorage and Alaska Southeast. And then in the Pacific Islands, our primary consortium partner is the University of Hawaii at Manoa. And then we also have consortium partners at Hilo and at Guam. So this is a really interesting opportunity and a really interesting resource for the USGS and the DOI to be able to engage with these universities and the students and researchers that they house. And as we engage with them, one of the things that we would like to do within PIAC is to promote early and mid-career development opportunities. And of course, for those of you who are later in your career, we're not negating you, and we find that they're very valuable. But one of our, to include in conversations and in projects, but one of our real goals is to try to grow some of the careers and the awareness in the early career stages so that people can start to understand some of the connectivity that they could reach to within their region, but contextualized with a larger worldview. So younger people in Alaska, or people earlier in their career in Alaska, identifying with some of the same challenges that we face in the Pacific Islands and starting to understand how they could crosswalk ideas, theories, and management options. And then, as Steve mentioned, in these systems, the landscape is truly part of the culture. And so part of the other aspect that we're really focused on is providing research and community and management engagement opportunities for students and educators across these two regions. This is, it's third in my list, but it's definitely one of the top goals that we have within PIAC, is to help develop these networks between the research and community and management. I think of it as a Venn diagram of all these people overlapping, because we have shared interests, and the science can inform the management can inform the science, and the community can inform the managers and the scientists of what the needs are around science for climate change adaptation. And then the other is to better connect researchers and managers, as I just mentioned, within a community context, but this is to bring us back into the cultural management needs of the cultural and natural resource management needs for climate adaptation. So as Steve mentioned, we had a number of meetings where we brought together scientists from both regions, and we discussed some of the research goals that would define the early stages of the PIAC relationship. And these are the three research goals that I thought I would share with you today. They are: what are the mechanisms by which climate-driven and related processes at higher elevations are linked downstream and through the watershed? So this often requires building interdisciplinary teams, because oftentimes in science, as you know, we have terrestrial ecologists, and then we have people who study coral, and then we have people who study cultural relationships of, for example, Hawaiians with their fish ponds. So suddenly you have to bring those three groups together to start to get at some of these mechanisms by which the different elevations are related through this process. The second is to find fine-scale processes and local heterogeneity and management options, and see how those mediate the impacts of climate-driven change. So this gets back to some of the needs that Steve mentioned around the fact that we have a paucity of science, but we do have a long history of cultural management, and there's a lot of interest in engaging around understanding the fine scale. And here we would talk about the INA and the local understanding of what is going on and how we can use that knowledge to better protect and manage the natural and cultural systems that we're living in. And then the third is, how can existing tools be modified or new tools be created to better predict and or mitigate the impacts of climate variability and to provide management actions for these high gradient watersheds. So what I'm going to do is, I'm sure you're interested to hear what our scientists are actually doing. So one of the things that we did, we have 7 projects that are ongoing and funded right now, and we're going to hear from a few of them who are able to put videos together to share with you today. And I'm going to actually just let them share their research and their reasons for being involved with PIAC in their own words.
Aloha, I'm Walter Boger. I'm a graduate student at University of Hawaii in Hilo. I'm working with Dr. Colbert and Tracy on the Wailuku River, which is the river behind me, to the front and back. And I'm from Maryland, where I got my undergraduate degree in geology. And I've been doing freshwater stream science for a couple years now.
Aloha, my name is Claire Whetstone. I am a senior student here at UH Hilo in the Marine Science Department. I have been hired on as a research assistant for the Wailuku project.
Aloha, my name is Finn Rio. I'm a student at the University of Hawaii Hilo and I'm a marine science student.
So this is our field site, the Wailuku River, which connects the world's tallest mountains, Mauna Kea and Mauna Loa, to coastal ecosystems in Hilo Bay. Vai in the Hawaiian language means fresh water, and Luku means destruction. Essentially, this river is the river of destruction. And so the Wailuku is very flashy in its magnitude and timing during storms. And so during these storms, they kind of export nutrients, organic matter, and organisms down to the Hilo Bay, which the coastal ecosystems in Hilo Bay rely on it. And they're also temporally synced to these storms for these nutrients. And since climate change is going to increase the severity and magnitude frequency of these storms, and also the duration of dry periods, it can throw off this kind of temporal balance that already exists. And this can threaten cultural, ecological, and commercial behind me. And we had a recent turbidity reading of 114 as well. And so these storms are packed full of exports.
There are shared similarities and differences between the rivers being studied here in Hawaii and Alaska. Both rivers have relatively small watersheds located on volcanoes and rainforest ecosystems. However, the source of water between the two is different. In Hawaii, it's fed by rain events and is very flashy, while the ones in Alaska is fed by glacier and snowmelt, which creates seasonal pulses. There are also similarities in important commercial and cultural fish. In Hawaii, for example, the wo'opu, which is shown here, begins its life cycle as an egg that is flushed out into the sea during storms. Then after several months, they swim back into the stream to breed, much like salmon. The wo'opu accomplishes their upstream journey using their fused pelvic fins as suction cups to climb, and it allows them to climb waterfalls. I got involved in the project because it was a great professional opportunity for me. I wanted to gain experience in freshwater research and also early career development, such as leading a team. Also, I wanted to live in Hawaii as well.
Hi, this is Rick Lader, and I am a research associate at the International Arctic Research Center, located at the University of Alaska Fairbanks. I've also lived in Alaska for a little while now, if you couldn't tell. I am the PI on a Pacific Islands Alaska CAST project, which seeks to translate existing downscale climate model results in Southeast Alaska and Hawaii. My team is doing this in the context of future precipitation extremes, which can relate to both flooding and drought. The steep gradient watersheds of Hawaii and Southeast Alaska drive the need for the Pacific Islands Alaska CAST collaboration, because common tools that work to inform climate issues elsewhere do not necessarily provide the granularity of information required in these two regions. Thus, we use and translate downscale climate data. Downscaling is a process that typically uses very coarse scale global climate model, or GCM data, to simulate regional climate at much higher spatial and time resolution. While we use GCMs for a big picture perspective, we often want more localized, in your backyard data, which is where downscaling comes in. I became involved in the Pacific Islands Alaska CAST collaboration because, over the years, I have worked on developing various dynamical downscaling datasets. While these products have helped to bridge the climate data gap, in Alaska in this case, we still need to improve on making these data more accessible for researchers and stakeholders that have an interest in climate impacts.
Aloha, my name is Tim Grabowski, and I am the unit leader of the U.S. Geological Survey Hawaii Cooperative Fishery Research Unit, based at the University of Hawaii at Hilo. Both Hawaiian ridge-to-reef systems, as well as Alaskan icefield-to-ocean systems, face potential of climate-driven changes in extreme flow events, such as floods and droughts, that could dramatically change how nutrients are retained and transported. The overall goal of this proposed project is to develop a multidisciplinary team to evaluate the effects of flow alteration on these watersheds. And for this project specifically, we're focusing on an invasive species in Hawaiian streams, the armored suckermouth catfish. And we will then compare and contrast our findings to those of a complementary study that is ongoing in Alaska that links hydrology to freshwater salmon growth in Southeast Alaska. And in particular, in these Hawaiian streams that we're looking at, the armored suckermouth catfish can form extremely large populations and can account for a significant proportion of the biomass that accumulates in these streams. So it's of interest to look at how that biomass changes through time by looking at the growth and recruitment of suckermouth catfish in these streams. And to accomplish that in a short amount of time, what we're going to be looking at are the otoliths of these fish. Otoliths are these acellular bony structures in the fish's head that are they're almost equivalent to human ear bones. What makes them really interesting and unique is that they form rings on them as they grow. And over the course of a year, these rings form what are called annuli, where during fast periods of growth, you have these relatively translucent parts of the otolith. And as growth slows down, say in the winter in a temperate climate, the growth rings become much closer spaced to each other. And you get these parts here that are relatively darker. And so by counting these annuli, or these rings around the otolith, we can determine not only the age of the fish, but by looking at the proportion of the otolith accounted for by each of these increments, estimate how big the fish was at the end of these growth seasons of each year. And from that, be able to estimate how fast the fish was growing in a given year and relate that back to flow conditions in the stream, if the stream has a stream gauge on it. So these data will provide resource managers with critical information of linking hydrology to the ecology of these streams, ridge-to-reef streams, as well as icefield-to-ocean streams, and guide decisions related to habitat restoration, flow management, invasive species control, and fisheries management.
So I hope you guys are enjoying the science. I do have one more to share.
That's the main goal, is can we observe how the reef functions, how the fish interact when we're not there. So we picked Keahole Point, so the most exposed westernmost point on Hawaii Island. So it's rough, it's exposed to all the elements, and the group that was willing to try this was Aqualink, View into the Blue, and the Mega Lab. Everything we're developing is brand new. It's never been tested before, and it has so many avenues for problems. So most people would look at that and say, nah, it's just not worth the risk. We don't know if it's gonna work. We know we're up against problems we can't even predict, but if it works, we just made the best observatory system on the planet.
You guys can see that we are working with a group of really dynamic researchers. And although you heard mostly from researchers and from student researchers in those clips, we also are working with a dynamic set of managers with these projects in the co-production fashion that the casks function in. There are 3 other projects that I just wanted to highlight we did not have time to put together videos for, but that are comparably important and interesting. And I think that one of the things that these research projects that you've just seen demonstrate is some of the things that we can do with PIAC that you may not be able to do with some of the traditional programs and mechanisms. You can hear from the last researcher that we're taking risks, we're exploring. So we're really encouraging the researchers and managers to identify, where do the challenges remain, where do the gaps remain, and what can we do to address them, and let's take some chances and let's take some risks and let's see what we can actually move the needle on. So there are so many opportunities that remain. Here on this slide, you can see at the top left, I think you can see my cursor or my mouse if I move it. So this is a fish pond in Hawaii. So what you can see here is all of this runoff, and this is probably what we look like right now. If any of you are following the news, we've had massive storms out here in the past couple of days, and there's been significant erosion on the islands. And I will quote what Steve said, because I actually liked his turn of phrase, which was the fact that the landscape and the culture are intimately connected here. And you can see that here in the fact that the cultural resources are being impacted by natural processes. So there's a natural interface between cultural and natural resource management in the islands. There's also significant concerns about some of the other challenges that climate intersects with. So some of the petroleum industry you see in the middle of this, if you've been paying attention in Hawaii, we also have some petroleum issues with petroleum leaking into groundwater, aquifers on Oahu, and contaminating people's drinking water across a large section of the island. So as climate changes, some of these other risks that are associated with other sectors beyond the natural and cultural resource management will be increasingly influenced by how we manage things like permafrost shifting, et cetera. You also can see that hazards will increase. So you see this landslide on the bottom left-hand corner of down here. This is a landslide in the islands. Alaska has many of those too. You saw earlier the glacial runoff and flooding. So these are challenges that we share across the region. So there are ample opportunities to collaborate across PIAC, not only within the USGS, within ecosystems mission area, which is where we sit, but also across some of the other mission areas to include some of the hazards and risks associated with climate change. So again, I would say that there are huge opportunities. I mean, I go back to my map, so it just emphasizes it with a geophysical scale, but the truth of it is that we also have as much breadth as you see here in terms of oceanscape or landscape. We have just as much breadth in terms of natural diversity, but also in terms of cultural diversity and richness and heritage and tradition across both regions. So there really is just significant opportunity to continue to move this forward. And I can speak for Steve, as well as our consortium partners, Scott and Darren, who lead the university consortium components of PIAC, that we are super excited with this first cohort of research projects and are really excited about how to move it forward. And Steve, I think with that, I will pass it back to you.
Thanks so much, Mary Vaughn. And yeah, again, very excited to see where this can go. As I think you've seen from our story today, that it's been in some ways a little bit of an unusual road to get us here, but in many ways it makes perfect sense. That again, we share many of the same challenges, but also have, again, tremendous opportunities for working together. And that if we can capitalize on the work that each of us are doing, learn from one another in terms of the science that we're doing, our approaches to adaptation, and then really emphasizing the importance of integrating the culture of these communities into the work that we do, that I think PIAC is bound to be a tremendous success. So thanks to everyone for joining us today. And I do think we left enough time that we could do some questions.
We do have one question in the chat already from Corinne, who I guess is posing this question to both Steve and to Mary Vaughn. She asks, do Indigenous people in Alaska have a similar system to, oh, forgive my pronunciation, Ahupua?
I can take that. In some ways, yes, in that there's an understanding of how these watersheds compose or comprise a whole system. But it is a little different than the Ahupua system in that it's not also incorporated into land tenure and the way that people have approached not exactly ownership of the land, but the management and the use of the land over time. So there are complementary ways of thinking about these watersheds, though they're not exactly equivalent in terms of that specific concept.
Katie Hinson asks, will the recent executive order on Indigenous knowledge inform this partnership?
I'll start. I think Steve will definitely have things to ask to that. Katie, I think in a sense it will, because it gives us the green light to really expand that aspect of what PIAC is striving to do. But in a sense, it doesn't change anything in terms of the fact that we have from the beginning been really committed to the fact that Indigenous knowledge is part of the solution to the future challenges that we face. So yes and no, I guess. The hope is that through that executive order that we will actually be able to increase funding to some of the knowledge production systems that are associated with Indigenous peoples across both landscapes that we might not have been able to previously fund under a more restrictive funding climate. Steve, would you like to add anything?
No, I would agree with that. That's a perfect way to put it. And that we were there already. And this is almost just like a reinforcement of the idea that we're looking in the right place, and again, maybe even have additional opportunities because of more ability to fund money or fund efforts in a way that we can better collaborate and partner with the Indigenous communities rather than just being scientists that come in and do sciencey things and leave. So very much hoping that it reinforces and adds to what we're already trying to do.
Cherie asks if you all are planning a symposium or conference in the future that will share the results of this work. And I think Heather may have also added in a link to a potential conference that y'all are putting on.
Yeah, that's one of many things that we hope to do. We have plans for a number of activities along those lines, but we also want to make sure that we're doing more than just producing reports, just holding sort of sciencey sorts of events of the type that you usually see a bunch of people and sometimes some managers and community members get together, but looking for ways that we can better push what we're doing out to the communities that live in these areas and understand how we don't take away from the story of that community, but maybe we can be a part of it, or that we can be invited to participate in the story of that community. So looking for additional ways above and beyond what we normally do as scientists to get that out there and share with one another.
I would say that is exactly on point, Steve. And the only thing that I would add to that is that one of the other things that we face both in Alaska and throughout the Pacific is having local capacity. So one of the other goals that we strive to achieve with some of these gatherings, meetings, the creatings of these cohorts of people who are working within the PIAC context is to build the local capacity within both regions so that we can move that knowledge base forward that is coming from both the science and cultural knowledge.
Charles asks whether heat factor was noticeable in both watersheds.
Might need some additional information on what's being asked there, but both the watersheds in Alaska and Pacific Islands that we're dealing with very much we're dealing with a variety of issues related to temperature increase. For us in Alaska, a large part of what you see is it basically plays out in terms of changes to the way that the glaciers are melting and behaving over time, and changes to snow melt and the difference between snow and runoff in these areas, and trying to understand that, how, if it gets warmer, we get more rain, how does that change the system versus just getting snow onto these ridge tops? Those are the kinds of things that we're playing with. And then that has to also interact with the direct impacts of temperature change on the water in these nearshore ecosystems themselves. So thinking about, well, what does warmer water that meets additional runoff from the glaciers mean? And trying to put all of those things together and understand what that tells us about how we manage these systems or how we adapt to these changes going forward. Those are some of the big sorts of changes that we're looking at.
Vanessa asks, and Charles, feel free to elaborate on your question if you feel the need to. Vanessa asks, did First People knowledge holders inform the research questions of the projects that you showed?
At this point, I think that it would be fair to say that we've concentrated on looking at the needs of a broad swath of the community. So taking information that we're getting or feedback that we're getting from other researchers, from resource managers, from both agencies and the local communities, as well as people from the communities themselves, and putting that together to inform the research questions. Where we would like to head with this, though, is very much a model where we're drawing from people within the communities, as equal partners in shaping those research questions and shaping the activities that we do. We're still a ways from that, I think, but we're certainly trying to do that, and that's one of the primary goals of what we're trying to accomplish here. And again, very much trying to get away from this model of scientists just coming into an area, doing the science and leaving. That we really want to make this a partnership, a meaningful collaboration, or what, again, we in the CAS community refer to as co-production sort of mode, where all of the different players and interested parties have a role in developing, executing, and then learning from the science that's done.
And I would also share that Alaska has definitely done an excellent job outside of the PIAC context, but within the ACC-CASC, which is Alaska CASC, right? So without engagement with PICASC, in terms of developing these relationships. And within the Pacific Islands CASC, we've also worked closely to try to principally, and I will admit it is in some ways a shortcoming, and it is still in evolution, but to try to help scientists not do the thing that Steve talked about, which is where they just sort of parachute in, they take the data they need, they say thanks, they eat something and they leave. So we've really worked on trying to develop better training and engagement opportunities for scientists to understand the impacts of not only their work, but also their attitudes and their conversations, and the fact that being there is actually changing relationships, which changes opportunities, which can change the way that we address challenges, et cetera. And so one of the really interesting things that we were moving towards right before COVID was part of what PIAC was going to do was set up some exchanges between the Pacific Islands and Alaska to be able to understand how we're each engaging with our indigenous communities from the scientific context, and to be able to empower voices from both sides to come together and understand our shared challenges around these issues and some of the solutions that may be able to carry us into the future. I would offer one thing, which is that even though we listed 7 projects and we listed names associated with them, we're not closed by any means. So if any of you who are on this webinar are interested in engaging further within a PIAC context, please do reach out to Steve and to me, or to any of the other scientists that you see whose names you recognized for entree into a discussion. But we'd be happy to grow this group. This isn't a small club that's full.
All right, if there are no more questions, then I'll thank our presenters. Thank you so much, Mary Vaughn and Steve, for this wonderful presentation.
Thank you. Y'all take care. Mahalo.